So in this question, you're given that z is root 3 plus I by root 3 minus I whole power 5. And you're asked to find the principal argument of this complex number. So first, let us try to find the general amplitude of this complex number, and then we'll get the principal argument later. So first, z is of the form some complex number power 5, right? Some complex number power 5. Root 3 plus I by root 3 minus I power 5. So this implies argument of z, can I write it as 5 times argument of root 3 plus I by root 3 minus I. This is the first thing that I can write, because argument of z power n is n times argument of z. Now, this complex number is of the form sum z1 by z2. We know that argument of z1 by z2 is argument of z1 minus argument of z2, right? So argument of root 3 plus I by root 3 minus I, argument of root 3 plus I by root 3 minus I is equal to argument of root 3 plus I minus argument of root 3 minus I, right? Argument of root 3 plus I minus of argument of root 3 minus I. Now what is the argument of this? For this, we try to convert this into polar form to find the argument, right? And we can also use our basic process to find the argument. So for this, tan theta is equal to 1 by root 3. Tan theta is equal to modulus of y by x. So this implies basic theta is equal to 30 degrees. And this complex number lies in the first quadrant. So in the first quadrant, argument is same as theta. Hence, the argument of this is 30 degrees. Now let us go to this. For this also, the basic argument tan theta is modulus of y by x. So mod of minus 1 by root 3, which is same as 30 degrees again. Sorry, which implies theta is equal to 30 degrees. But this does not belong to the first quadrant, hence 30 is not the amplitude. So what is the quadrant correspond to this? X is positive, y is negative. Hence this belongs to fourth quadrant. Hence argument is equal to minus 30 degrees. So here argument is plus 30 degrees, here argument is minus 30 degrees. Hence the effective argument of this is 30 degrees minus of minus 30 degrees, which is equal to 60 degrees. Or I can write as pi by 3. So argument of this is pi by 3. Hence argument of z is equal to 5 pi by 3, which is effectively equal to 300 degrees. But you're asked to find the principal argument of z. So 300 is not the principal argument. So if you try to plot this complex number on the argand plane, so you get this complex number z somewhere corresponding to 30 degrees, somewhere corresponding to 300 degrees, sorry. So if you try to measure this along the principal argument direction, what is the answer? So this angle will be the principal argument. So if this angle is 300 degrees, this angle is 60 degrees with a negative sign, right? Because you're going in clockwise direction. Hence, the principal argument of root 3 plus I by root 3 minus I whole power 5 is minus pi by 3. So in this question, you're given that Z1 bar are a pair of conjugates and Z2 bar are another pair of conjugates. If that is so, you're asked to find argument of Z1 by Z2 bar plus argument of Z1 bar by Z2. So what will be this argument? Will it always give you a specific number? So let us try to analyze this. So what is argument of Z1 by Z2 bar? This is argument of Z1 minus argument of Z2 bar. Plus, what is argument of Z1 bar by Z2? Argument of Z1 bar minus argument of Z2. So that is equal to So let us combine the like terms correspond to Z1 and Z1 bar and Z2 and Z2 bar. So this is equal to argument of Z1 plus argument of Z1 bar minus argument of Z2 minus argument of Z2 bar. So that is equal to, so you can very clearly see argument of Z1 bar as we have derived, it is minus of argument of Z1. So these two combinedly give you 0, and this is minus of again argument of Z2 plus argument of Z2 bar. So what is argument of Z2 plus argument of Z2 bar? This is again equal to 0. So you get 0 minus 0 equal to 0. So this value will always be equal to 0. So in this question, you're asked to find the modulus and arguments of these two complex numbers, and you're also asked to express them in polar and Euler form. So 1 plus I whole power 50 has to be expressed in polar and Euler form. Root 3 minus 3I whole power 100 should also be expressed in Euler and polar forms. So now let us start with our first question. So to find the modulus and argument, let us use the properties of modulus and the properties of arguments. So first, let us take Z as 1 plus I whole power 50. And mod Z is nothing but, as you can see, Z is of the form some complex number power n. So mod Z can be written as mod of 1 plus I whole power 50. And this can be written as mod of 1 plus I whole power 50, because mod of Z power n is mod Z power n. And this can be written as, what is mod of 1 plus I? Mod of 1 plus I is root of x square plus y square. Root of 1 square plus 1 square, which is nothing but root 2 whole power 50. So which is equal to 2 power 25. So modulus of Z is 2 power 25. Next, what is the argument of Z? Argument of Z is nothing but argument of 1 plus I whole power 50, and this can be written as 50 times argument of 1 plus I. Argument of 1 plus I whole power 50 is 50 times argument of 1 plus I. Now what is the argument of 1 plus I? Straightforward, right? Pi by 4, right? Because tan inverse of 1 by 1 is pi by 4. So we have 50 times pi by 4. That is equal to 25 times pi by 2. So the argument of Z is 25 times pi by 2. Obviously this is not the principal argument, right? So to convert this into principal argument, you have to bring it into minus 180 to plus 180. So let us see the ray position correspond to 25 pi by 2. So if you take the Argand planes quadrant diagram, 25 pi by 2 is 25 times 90 degrees. So 4 90 degrees corresponds to a complete round. 8 times pi by 2 corresponds to another complete round. So on. So 24 pi by 2 corresponds to 6 complete rounds. 24 times pi by 2 corresponding to 6 complete rounds. So 25 pi by 2 corresponds to 6 rounds plus a 90 degrees. So the ray is stopping in this position. Can you observe this? Hence, the principal argument becomes pi by 2. So principal argument of Z is equal to pi by 2. So the mod is 2 power 25. The argument is pi by 2. Hence, the polar form of 1 plus I whole power 50 is nothing but 2 power 25 times cos pi by 2 plus I sin pi by 2. And the corresponding Euler form is 2 power 25 times e power I pi by 2. 2 power 25 times e power I pi by 2. So I hope the working is quite clear. Next, let us go for our next question. So root 3 minus 3i whole power 100. So first let us find the modulus of this. So mod z is nothing but mod of root 3 minus 3i whole power 100, right? And what is the mod of this? So the mod of this is root of root 3 whole square is 3 and 3 square is 9. So root 3 whole square plus 3 square, that is equal to root 12. Root 12 is nothing but 2 root 3. 2 root 3. So now mod z is nothing but 2 root 3 power 100. So this completely becomes 2 root 3 whole power 100, that is equal to 2 power 100 times 3 power 50. So the argument, the modulus of this complex number is 2 power 100 times 3 power 50. Now let us find the argument of this complex number. So to find the argument, theta is equal to tan inverse of modulus of minus 3 by root 3. That is tan inverse of root 3 becomes 60 degrees. And this complex number belongs to fourth quadrant. X is positive, Y is negative. Hence, the argument becomes minus pi by 3, minus 60 degrees. So the argument of root 3 minus 3i is minus 60 degrees. So argument of root 3 minus 3i power 100 is equal to 100 times minus pi by 3. 100 times minus pi by 3. That is equal to, so it's nothing but minus of 33 pi plus pi by 3, right? If you just convert this into mixed fraction, this is 33 pi plus pi by 3. So that is equal to, so if you want to convert this into the standard principal argument, so let us see where this number lies. It's nothing but minus 33 pi minus pi by 3. So minus 33 pi, you go in the clockwise direction. So every even multiple of pi corresponds to complete rotation. So minus 32 pi is correspond to complete rotation. So minus 33 pi, you come here. And minus 33 pi minus 60 degrees, you go 60 degrees above. So the argument, the ray stops in the second quadrant. And this angle is 60 degrees. So what is the principal argument correspond to this? You have to measure from this side, which is equal to 2 pi by 3. So the principal argument of the complex number correspond to minus 100 pi by 3 is plus 2 pi by 3. So I hope you understand the process. First, I'm trying to see where the ray is stopping. And once I get the ray, I'm measuring the argument of that in the conventional direction. So 2 pi by 3 is the argument. Hence you got the modulus and the argument. Hence the complex number can be written as 2 power 100 into 3 power 50 cis 2 pi by 3 or 2 power 100 3 power 50 e power I 2 pi by 3. So this is the polar form, this is the Euler form.